Hi Warriors, and welcome back to semester 2 of the 2021 school year. I'm Miss Holloway and I'll be your Algebra 2 teacher for semester 2. You can read a little bit about me in my welcome letter, and hope we have a good year together. I know that we will, whether you're going to be in person or on Zoom. Today we're going to start our first notes and cover exponent rules. I know we don't have a whole lot of time to kind of do get to know you things, but we're going to go ahead and jump right in with exponent rules. And you can see here our exponent rules properties, and I'm going to leave them up there while we're taking notes. If you will, find your notes from chapter 5-1 or .1 integer exponents in scientific notation. So if you don't have these printed out, please get your journal and open up to a blank page, and we'll take notes on that. So we will have questions at the end during the discussion of these notes, so make sure that you are writing your notes down and paying attention. We will have questions at the end. So I'm gonna work on these notes in the whiteboard and keep the exponent rules up there for us. So there's a couple of things here in the notes. It says let a be a real number such that a cannot equal 0, and let n be the integer. So there's a couple of things maybe that you haven't reviewed yet, and that's our 0 exponent rule, and that's here. I'm going to highlight it with my right here. That anything to the 0 power is equal to 1. So I want us to think about that. You did your review, and if I think about numbers being multiplied together, that's what an exponent is, right? So if I say that it's 2 to the third, well, I know that that means that 2 is being multiplied 3 times, right? So that exponent just tells me a quick way to show me how many times that piece is being multiplied. So if I have 2 to the 0, well, if 2 is not being multiplied any times, then I have to think about the variable, the coefficient in front of 2, which is 1, right? So my answer is always 1. So anything raised to the 0 power is always 1. Little bit of kicker there. Anything raised to a negative power, they give you an example there, a to the negative m, is actually going to be in the denominator. So it looks like this, a to the m, like that. And your exponent then is positive, not negative. And it's flip-flopped the other way too. So if I say that 1 over a to the negative m, in order to make that exponent positive, I have to put it in the numerator like that. Okay? Alright, so let's start with our first couple of examples. This will go with our product rule. A to the m times a to the n is equal to a to the m plus n. So I want you to notice a couple of things here. What didn't change? Your base does not change. Also, your base must be the same. Bases must be the same, okay? That's super important. You cannot follow the exponent rules unless your bases are the same. Bases meaning here is a, where these are your exponents, okay? Do the next one. So a b to the m power, notice your parentheses there, that means that it's a power rule. So it's power of a product rule. So if this is a to the 1 power and b to the 1 power, then this means that it's a to the 1 times m and b to the 1 times m. So your answer here is a to the m power times b to the n power. Let's keep going. A, m, n. This is another power of a product rule. So anytime that you have exponent being raised to another exponent, then we're multiplying them. So your answer looks like this, a to the m n. Okay, m times n. Next one is a to the m divided by a to the n. This is your, quotient rule, sorry. So we're subtracting, just like multiplication. Multiplying is adding, dividing is subtracting. So it's a to the m minus n. It gets a lot more fun when we put numbers with it, promise. Next one, a divided by b to the m power. This is the same thing as the power rule, except you're applying it to a fraction. So same thing, you're going to apply it to the a and the b. A to the m power over b to the m. The important thing here is that you have parentheses. If you don't have parentheses, then it's only applied to that one base. All right, last one here, a divided by b raised to the negative m. We kind of talked about this. Let's apply the power rule first. So it's a to the negative m and b to the negative m. And in order for me to make these positive, I need to switch them. So the a will go to the denominator and the b will go to the numerator. And I ran out of room. So it'll be b to the m power over a to the m power. All right, so let's apply these. Let me scroll down here to some examples. So our first example in our practice is 4 to the 0 power. And I'm going to leave these up here and just write them down in a row. So our A example is 4 to the 0 power. So if I don't multiply anything together, then my answer is going to be 1, right? B, my next is 0 to the 0. Oh, tricky, right? Well, if I don't have any zeros, still the same answer, 1. Trick question. C, 1/5 in parentheses raised to the negative 2 power. I'm going to follow this out and follow it through steps. So I have 1 to the negative 2 power, second power, and 5 to the negative second power. I need to make these positive. So remember, always positive. Make your exponents positive as much as you can. So I have 5 to the second power divided by 1 to the second power. And let's go ahead and multiply these out. 25 over divided by 1. My answer here would be 25, because 25 divided by 1 is 25. So let's move on to D. 1 divided by 3x to the negative second power. We're going to apply our exponent, our power, to each of our pieces here. So I have 1 to the negative second power, and I have 3 to the negative second power, and x to the negative second power. So don't forget that 3x, those are separate there. If it's power to a power, then you're applying it to both. Making it positive, 3 squared x squared divided by 1 squared. Let's multiply this out. I have 9x squared divided by 1, and your answer there is just 9x squared. Kind of ran out of room, huh? All right, let's move on to E. 1 divided by 3x to the negative second. This one's a little bit tricky, right? Since I don't have a power over here, there's really not any need for me to have the exponent. So I'm going to go ahead and take it out of the exponent. This makes it a little bit more clear of which is being raised to a negative power and which is not. So since only the x is being raised to a negative power, that's the only base that I'm going to move up. So it's x squared divided by 3, and that's going to be your answer there. It's really 1 times x squared, but I went ahead and skipped a step. All right, let's move on to F. 2x to the 0 power. All right, this is the same thing like last time, except they don't have the tricky parentheses there. Only x is being raised to the 0 power, so that is 1. So I have a 2 times 1. I'm not skipping a step here because I want to show it to you, that this becomes just 2, right? So it would be different if it looked like this. Then that would be all 1. But since it's only being raised to the x, then it would just affect the x value. All right, G. Oh, I missed one. Nope. Oh, ooh, look at that. Didn't even know it. There it was there. So since all of it's being raised to the 0, I'm not going to skip a step here because I want you to see. This is 2 raised to the 0 power and x raised to the 0 power. Therefore, if both of them are 1, then my answer is 1, okay? So that will follow the 0 power rule. All right, let's move on to H. Last one. I have 2 to the 0 and x, y to the 0. All right, look at this. This is being raised to the 0 power, and this is being raised to the 0 power. So what are they? It's 1 times x times 1. Now I'm like being really dramatic here and drawing it out. So I just have 1x, or, hey, just x, because we don't need that variable. It's an understood one, right? So that concludes our just more simplified ones, and we have 4 examples to do together, and I'm going to move a little bit quickly, and then we're going to do one together when you come back to the synchronous. So I'm going to get my next whiteboard. If you don't have a personal whiteboard, you should really get one. When we do activities together on class, you can hold it up when we're doing Zoom, and it's easier to see. All right, let's go to I. 12x squared y to the negative 4 divided by 6 times x to the negative 1 y squared. Okay, before I do anything, I want to make sure that my values are positive. That's, for me, that's my first step, is I want to have positive values so I don't get confused with all the negatives, right? So any negative value or negative exponent, I'm going to move to the other side. So my 12 and my x squared stay in the numerator. My y to the negative 4th moves down, and my x to the 1 moves up. 6 y squared y to the 4th. All right, so this kind of looks funny now because we haven't simplified it all the way yet, but let's look and see what we're going to use. We're going to use our product rule here. And since we have the same base of x, then we're going to put our x's together. And we have the same base of y, we're going to put our y's together. I'm not going to mess with my numbers yet. I know what you're thinking. Hey, we can reduce that. We can, I know. So I'm going to add my 2 plus my 1, and I get a 3, okay? And I'm going to add my 2 plus my 4, and I get a 6, right? I cannot reduce these any further because they don't have the same base, all right? That's where the rule comes into play. All right, but now I can reduce this. 12 divided by 6 is 2. Move on down here just for this one thing. So I reduced my value, and this is what a simplified exponent, using exponent rules, looks like. All right, let's move on to J. This one has parentheses. I bet it's going to be tricky. All right, so I have 3 u to the 2nd power, v to the negative 1 power, divided by 3 to the 3rd, u to the how about u, not y, u to the negative 1, and v to the 3. Copying is very important, right? Copying correctly. All right, so since I have parentheses, I'm going to deal with my power first. It's power to a power rule, using the power rule. So it's applied to everything. Don't forget that. It's applied to everything, even if it doesn't have an exponent. It still has an exponent. It's 1, remember? So I have 3 to the negative 2, u to the negative 4 because I'm multiplying, v to the negative 2 because I'm multiplying, divided by 3 to the negative 6th, u to the positive 2, because negative times a negative is a positive, v to the negative 6th. Okay, just like before when we had all those negatives, let's deal with these. Looks like the only thing staying is this one, so everything else is moving. So I'm going to move my 3 to the 6th power. I'm going to move my v to the 6th power. Everything on the top moves down, so it's 3 to the 2nd, u to the 4th, u to the 2nd, because that one didn't move, and v to the 2nd. All right, so now let's do our fancy work, right? So because we have quotient here, right, it's being divided. I have same base, and they're being divided, so I'm going to subtract. 6 minus 2 is 4. Well, what do I do with that number? Do I put it on the top or the bottom? Well, 4 is positive, right? So when it's positive, it goes on the top, 3 to the 4th, okay? Here again, same base, v to the 6